everyone, my name is Bharti Patel, Assistant Professor Computer Science and Engineering Department, Chhattisgarh Swami Vivekanand Technical University, Bhilai. So let's begin with the detailed understanding of the today's lecture on advanced image manipulation and enhancement techniques. So starting with the image sharpening. In this we should learn the importance of image sharpening, techniques for sharpening images, understanding edge enhancement. So what is the image sharpening? Image sharpening is the process of enhancing the edges and details in an image to make it appear sharper and more defined. It is an important aspect of image processing and is often used in photography and computer vision applications. When an image is captured, it may be affected by various effects such as camera shake, motion blur or less distortion, which can result in a loss of sharpness and detail. So there are several techniques for image sharpening, including unsharp masking, high pass filtering and deconvolution. So image sharpening is particularly important in applications such as medical imaging, where the accurate representation of fine details can be critical for diagnosis and treatment. It is also important in fields such as macroscopy and astronomy, where images of small or distant objects may be blurry or indistinct. Overall, image sharpening is a powerful tool for improving the visual quality of images and is widely used in various industries and applications. So some techniques are there for image sharpening. There are several techniques for sharpening images using Python, including unsharp masking, high pass filtering and deconvolution. Here is an overview of each technique and how it can be implemented using Python. So first is unsharp masking. Unsharp masking is a common technique for sharpening images, which involves creating a blurred vision of the images, subtracting it from the original image and adding the result back to the original image. This process enhances the contrast between adjacent pixels and increases the edge details in the images. In Python, you can use the CV2 Gaussian blur function and CV2 add weighted function in OpenCV to apply unsharp masking. Here is an example code. You should apply this code on your system and you can get the output. So in this code we have to learn that first we have to import the library function, then load the image, after that apply unsharp masking Gaussian blur function and add weighted function, then show the result. So this code applies unsharp masking to the input image using a Gaussian blur with a kernel size of 0, 0 and a sigma of 3, which is predefined. So second one is high pass filtering. High pass filtering is another technique for sharpening images, which involves removing the low frequency components of an image and keeping the high frequency components such as the edges and details. In Python, you can use the CV2 filtered 2D function in OpenCV to apply a high pass filter to an image. So here is an example code. In this example, you should learn that we have to import again the library function as numpy, then we have to load the image, apply high pass filter by applying the method or by applying the function of filter 2D, then show the result. So this code applies a high pass filter to the input image using a kernel with a central value of 9 and -1 for the surrounding values. Third one is deconvolution. Deconvolution is a more advanced technique for sharpening images, which involves revising the blurry process that cause the loss of sharpness and detail in an image. It can be a powerful tool for enhancing the visual quality of images, but it requires knowledge of the blurring function that was applied to the image. In Python, you can use the SkyPy.signal module to perform deconvolution. Here is an example code. In this code, we can see that we have to import the library function, which is mandatory to import. Then we have to load the image or input image. After that, we have to perform deconvolution by applying some functions which is written here. Then show the result by image show. So, in summary, we can say this code performs deconvolution on the input image using a kernel of ones with a size of 5,5, which is predefined, and normalizing it to create a blurry function. So, the ffconvol function is used to perform deconvolution. So, what is edge enhancement? We have to learn that how it is applicable by using Python. So, edge enhancement is a technique used to improve the clarity and definition of the edges in an image. It can help to make an image appear sharper and more defined by emphasizing the transitions between area of different colors or intensities. There are several methods to perform edge enhancement in Python, including first one is Laplacian filtering. Laplacian filtering is a common method for edge enhancement, which involves convolving an image with a Laplacian kernel to detect the edges. In Python, you can use the cv2.laplacian function in OpenCV to apply this filtering method. Here is an example code. In this code, we can see we have to import the library functions, then we have to load the image, after that we have to apply the Laplacian filtering, and then we have to show the result by image show. So, this code applies Laplacian filter to the input image by first converting it to grayscale and then applying the cv2 Laplacian function to the grayscale image. Second one is high pass filtering. High pass filtering is another method for edge enhancement, which involves removing the low frequency components of an image and keeping the high frequency components, such as the edges and details. Details means information about the images. So, in Python, you can use the cv2.filter2d function in OpenCV to apply a high pass filter to an image. So, here is an example code. In this code, first of all, we have to import the library function as numpy, then we have to load the image, then apply high pass filter and then show the result by image show. So, this code applies a high pass filter to the input image using a kernel with a central value of 8 and -1 for the surrounding values, which is already predefined here. So, next one is unsharp masking. Unsharp masking is a technique that can also be used for edge enhancement, as it enhances the contrast between adjacent pixels and increases the edge details in an image. In Python, you can use the cv2.gaussian blur function and cv2add weighted function in OpenCV to apply unsharp masking. So, here is an example code. Same as previous code, we have to import the library function, we have to load the image with specified image format, then we have to apply unsharp masking functions, that is Gaussian blur function and add weighted function, then show the result. So, this code applies unsharp masking to the input image using a Gaussian blur with a kernel size of 0,0 and a sigma of 3. So, overall edge enhancement is a powerful tool for improving the visual quality of images, and there are several methods that can be used to implement it in Python. So, next subtopic is removing noise. So, we have to learn that what is the importance of removing noise and techniques for removing noise and understanding about the noise reduction. So, starting with the importance of removing noise. Removing noise is the process of reducing or eliminating unwanted or irrelevant information from an image. Noise is any random variation in an image that is not part of the underlying structure or signal and can be caused by factors such as low light conditions, camera sensor limitations or interference in data transmission. Removing noise is important in image processing because it can improve the clarity and quality of the image, making it easier to analyze and interpret. For example, in medical imaging, noise reduction techniques can improve the accuracy of diagnosis and treatment planning by making it easier to see the underlying anatomical structures. In computer vision applications, removing noise can improve the performance of algorithms by reducing the amount of irrelevant information that needs to be processed. So, some techniques are there for removing noise. So, there are many techniques for removing noise in image, ranging from simple filtering methods to complex machine learning algorithms. Some of the common techniques for removing noise include: first, Gaussian filtering, second, medial filtering, third, wavelet denoising, and fourth one is deep learning based denoising. So, overall, removing noise is an important step in image processing that can improve the accuracy and reliability of image analysis and interpretation. So, here are some techniques for removing noise from images using Python. First is Gaussian filtering. Gaussian filtering is a popular technique for removing noise from images. In Python, you can use the CV2.Gaussian blur function, as we discussed already, from the OpenCV library to apply a Gaussian filter to an image. The function takes the input image and the standard deviation of the Gaussian kernel as parameters. As shown in this particular code, we can see we have to import the library function, then read the image and apply the Gaussian blur function. Second is median filtering, which is very common filtering method. Median filtering is another popular technique for removing salt and pepper noise from images. In Python, you can use the CV2 median blur function from the OpenCV library to apply a medial filter to an image. The function takes the input image and the size of the median filter as parameters. So, here in this code we can see we are importing the library function, then we are taking the image, after that we applied median blur function. So, third one is wavelet denoising. Wavelet denoising is a technique that uses a wavelet transform to decompose an image into multiple frequency bands and then removes noise from each band separately. In Python, you can use the PyWT library to perform wavelet denoising. The pywt.wavedec2 function can be used to perform the wavelet decomposition, and the pywt.wavrec2 function can be used to reconstruct the image after denoising. So, after applying this code, we can see the analysis of the image. So, here we are taking the library function, then again we have to take the input images, then we have to perform all the functions which are predefined here. Then the fourth one is deep learning based denoising. Deep learning based denoising is a more recent technique that uses deep neural networks to learn how to remove noise from images. In Python, you can use libraries such as TensorFlow or PyTorch to implement deep learning based denoising. Here is an example using TensorFlow. So, by this example, we can learn that we have to import the libraries. Again, here we are importing TensorFlow as TF. Then we have to take the image as image read. Then we have to perform the denoising functions which are mentioned here. And one important point that we have to note, that for the deep learning based denoising approach, you would need to first train a denoising model using a data set of noisy and clean images. So, next is understanding about noise reduction. So, noise reduction is a common task in image processing that involves removing unwanted variations or distortion in an image that are not related to the underlying signal or information. Noise can be introduced into an image due to various reasons, such as sensor limitations, data transmission errors, or environmental factors. There are several techniques that can be used for noise reduction in images, and the choice of technique depends on the type and characteristics of the noise, as well as the desired level of noise reduction and preservation of image details. One common technique for noise reduction is filtering, which involves modifying the pixel values of an image using a mathematical function or operator that takes into account the neighboring pixel values. There are several types of filters that can be used for noise reduction, including first, Gaussian filter. This filter applies a Gaussian distribution of the pixel values in the image, which smooths out the noise while preserving the edges and details of the image. Second, median filter. This filter replaces each pixel value with the median value of its neighboring pixels, which can effectively remove noise while preserving the edges and textures of the image. Third is bilateral filter. This filter applies a weighted average of the neighboring pixels to the pixel values in the image, taking into account both the spatial distance and the intensity difference between the pixels. So, this can be effectively remove noise while preserving the edges and fine details of the image. Other techniques for noise reduction include wavelet based denoising, which uses wavelet transforms to decompose an image into different frequency bands and selectively remove noise from each band, and non-vocal means denoising, which compares the similarity between patches of the image to selectively remove noise while preserving the structure and texture of the image. In Python, we can use libraries such as OpenCV and scikit-image to apply different noise reduction techniques to an image. For example, to apply a Gaussian filter to an image using OpenCV, we can use the CV2 Gaussian blur function as we discussed previously, while to apply a median filter, we can use the CV2 median blur function. To apply a bilateral filter, we can use the CV2 bilateral filter function. So, next subtopic is image restoration. Why it is important, we have to see in the further lectures. So, importance of image restoration and the techniques for restoring images, understanding, cloning and healing. So, first we have to understand the importance of image restoration. Image restoration refers to the process of improving the visual quality of a digital image that has been degraded by various factors such as noise, blur, compression, artifacts or other distortions. The aim of image restoration is to recover the original image or an image that is as close as possible to the original. So, image restoration is an essential task in various fields such as medical imaging, astronomy, remote sensing, forensics and surveillance, where high quality images are crucial for accurate diagnosis, analysis and interpretation. Image restoration is also important in the field of computer vision, where it plays a significant role in improving the performance of various computer vision applications such as object detection, recognition and tracking. Image restoration algorithms can be used to enhance low quality images making them suitable for further analysis and processing by computer vision systems. So, what is restoration techniques? There are several techniques for restoring images, and the choice of technique depends on the type of degradation that has affected the image. Some common techniques for restoring image include: first, spatial filtering; second, frequency domain filtering; third, deconvolution; fourth, super resolution; fifth, inpainting, and sixth one is deep learning based methods. So, Python is a popular programming language for image processing and computer vision tasks, and it provides several libraries and packages that can be used for image restoration. Some commonly used packages for image restoration in Python include: first, OpenCV; second, scikit-image; third, TensorFlow; fourth, PyTorch; and fifth, DIPy. So, techniques for restoring images using Python code is here, with some example which is going to be show the restoring methods, that how to restore the image using OpenCV and scikit-image packages. So, after applying spatial filtering with OpenCV, we can see this code. In this code, we have to learn the libraries and packages. First, we have to import NumPy as NP, then read the image with the specified format. After that, apply a Gaussian filter with a kernel size of 3 × 3, which is predefined here. Then apply a Gaussian blur function with sufficient value. Then display the filtered image, and we can compare the original image with the filtered image by ImageShow function. Second is frequency domain filtering with scikit-image. For that, again we have to import the libraries and packages, then we have to read the image by ImageRead, then convert the image to grayscale image. Why we are converting here? So that we can reduce the complexity, and we are using here filters.Gaussian function for this image filtering. After that, apply a veneer filter in the frequency domain for the extra feature addition. Then we have to display the restored image, and we can show by ImageShow function. Then third one is deconvolution with OpenCV. Again we have to import the libraries and packages. Here we imported as CV2 and NumPy as NP. Then read the image with ImageRead by specified format of image, like PNG we are using image.png. Then define the kernel for the blurring process and apply the blurring process to the image with some functions. Then apply the veneer deconvolution process to the blurred image and display the restored image and compare that restored image with the original image by ImageShow function. So, next is inpainting with scikit-image. This is also very important. So, we have to learn that how to use this inpainting method with scikit-image. First of all, we have to import the libraries according to the restoration process. Then we have to read the image by ImageRead. Again we are taking PNG as image format here. Then define the coordinates of the damaged region. We have to identify the region which we want to filter. Then we have to apply the inpainting process to the image, which will provide the area for masking process. Then we have to display the restored image by ImageShow. So, we are going to discuss about the cloning and healing. Cloning and healing are two common image editing techniques used to remove unwanted objects or blemishes from an image. In Python, these techniques can be implemented using the OpenCV library. Cloning involves copying a region of an image and pasting it over another region to cover it up. The cloned region is selected based on its similarity to the region being covered up. The following code demonstrates how to use the cv2.clone function in OpenCV to remove an object from an image. By this code, we can learn that how to use this cloning function. So, here we have to import the library, then we have to load the images, input images, then define the region of the image to be removed. Then take a clone for that particular region of the image to cover the removed region and replace the removed region with the cloned region. Then display the modified image and we can compare with the original image by image show function. Healing involves removing unwanted objects or blemishes from an image by blending the surrounding pixels over the blemish. The following code demonstrates how to use the cv2imppaint function in OpenCV to heal an image. So, by this code we can learn that how to use that healing function. For that we have to import the libraries, then load the image. After that we have to define the region of the image to be healed. Then apply the inpainting process to the image that is going to be healed. Then display the modified image by image show. In this example, the cv2.imppaint function is used to remove the specified region from the image using the specified method that is called here as cv2.imppaint_TELEA. The second parameter is a mask that specifies the region to be removed, and the third parameter is the size of the neighborhood used for the inpainting process. The resulting image is then displayed using the cv2 image show function. So, adding text and watermarks are the another subtopic. So, in this we have to learn the importance of techniques for adding text and watermarks and understanding about the typography. So, what are the importance of adding text and watermarks? Basically, adding text and watermarks to an image is a common technique used for various purposes such as branding, identification and communication. Text can be used to add captions, titles or descriptions to an image, while watermarks can be used to protect the image from unauthorized use or to identify the owner or source of the image. So, text can be added to an image using various fonts, sizes, colors and styles to create different effects and convey different messages. Watermarks on the other hand are usually semi-transparent images or text that are overlaid on top of the original image. They can be used to protect the image from unauthorized use or to identify the owner or source of the image. Techniques for adding text and watermarks. In Python, there are various libraries and techniques available for adding text and watermarks to images, include Pillow and OpenCV. So, adding text to an image using Pillow library, this is the code. By this code, we can identify that how to use that Pillow command for watermarking. Then adding watermark to an image using Pillow library, this is the code through which we can add the watermark to an image. Adding text and watermarks on an image using OpenCV library. So, this is the code through which we can add watermarks and text to an image. In this example, the cv2.putText function is used to add text to the image and the cv2addWeighted function is used to add the watermark to the image. So, in conclusion, basic image manipulation and enhancement techniques are essential for various image processing applications, including digital photography, computer vision and graphic design. These techniques allow us to resize, crop, rotate, flip, adjust brightness and contrast, color balance and apply different types of filters to the images. Thank you.